Hello everybody, today we are going to discuss the derivatives of the inverse trigonometric functions, the hyperbolic functions and the inverse hyperbolic functions. Here we have the graphs of the inverse trigonometric functions with domain and range of each for your knowledge, and the table of derivatives of the inverse trigonometric functions here. For example, if you wanted to find y prime where y equals sec inverse e to the power 2x, so you have to remember this rule where u here is e to the power 2x here. So if you wanted to apply this rule directly, you can find that y prime equals, as you can see here, u prime, which is the derivative of e power 2x. So the derivative of e to the power 2x is 2 e to the power 2x. So here e to the power 2x, its derivative is 2e to the power 2x, and you can substitute u here in the denominator where u is e to the power 2x. So you can find the final answer here, which is 2 over root e to the power 4x minus 1. Another example. If you wanted to find y prime of each of the following functions, you have to write the rule, and you can substitute in this rule directly, where u here is 5x plus 2, so you can substitute in this rule. U here is x squared minus 5, and in this problem u here is x to the power 3 minus 2x plus 1. Just direct substitution in the rule. Just you have to write the rule and you have to substitute here. For example, here you have u prime, which is the derivative of this bracket, which is 3x squared minus 2 over absolute u, absolute of this expression, times root u squared, this bracket to the power 2 minus 1. And you can find here also u, which is x over 6. You can directly substitute in the rule to find the final answer. If y equals the sine tan inverse of x over root 1 minus x squared, show that y double prime equals 0. So we have here, this problem is absolutely complicated. If you wanted to find the derivative using the classical methods, you have to simplify this problem. So we can assume that here we have sine bracket. So if you can assume this bracket as theta, therefore theta equals tan inverse of x over root 1 minus x squared. So you can deduce that tan theta, by applying tan theta for both sides, so tan inverse will be cancelled. So tan theta equals x over root 1 minus x squared. This is theta, and in this right angle, the triangle, this is theta. The tan theta, which is opposite over adjacent, opposite, which is x, adjacent, which is 1 root 1 minus x squared. And using the Pythagoras theorem, you can find the length of the hypotenuse, which is 1. So you have to remember that you have to find the derivative of y equals sine theta. So since y equals sine theta, you can find here sine theta, which is opposite over hypotenuse, which is x over 1. So sine theta equals x. Since sine theta equals x, so y prime equals 1 and y double prime equal 0, which is required to prove. The hyperbolic functions, we have different applications of the hyperbolic functions, and these are the hyperbolic functions. Here we have hyperbolic sine, hyperbolic cosine, and sometimes we call them sine x, cosine x, and so on, and hyperbolic tan, hyperbolic cosec, hyperbolic sec, and hyperbolic cotan. You have to remember these rules well. And here we have the graphs of the hyperbolic functions with domain and range of each for your knowledge, and the inverse hyperbolic functions. with domain and range. And the derivatives also of the hyperbolic functions, you must memorize these rules well. Also, we can see here to check that the functions, the hyperbolic functions, which one of them is even or odd. As you can see here, the hyperbolic cosine and the hyperbolic sec are even functions and the other functions are odd. For example, if we have e to the power, we have to prove that e power x equals hyperbolic cosine plus hyperbolic sine. You have to prove that e power x equals cosine x plus sine x. Okay, here we have cosine x, which is e to the power x plus e power negative x over 2, plus the hyperbolic sine, which is e power x minus e power negative x over 2. Just direct substitution using the rules of the hyperbolic cosine and the hyperbolic sine. So if you can take 2 as a common factor here, you can find that e power negative x minus e power negative x equals 0. So you have 2 e power x over 2. The final answer is e power x. Another example, prove that e power negative x equals cosine x minus hyperbolic sine x. Just direct substitution here. The hyperbolic cosine here, this is the rule, and this is the rule of the hyperbolic sine. Take 2 as a common denominator here, down as a common denominator. So you can simplify your problem as e power negative x minus e power negative x equals 0. So we have 2 e power x over 2, which is e power negative x, 2 e power x here we have e power x minus e power x equals 0, and e power negative x minus negative e power negative x equals 2 e power negative x. So the final answer is e to the power negative x here. To prove that cosine squared minus sine squared equals 1, you can say that the left hand side and substitute the rule here, the cosine squared and the rule of sine squared. Evaluate the brackets and simplify. So we have 2 here and 2 here in the denominator. 2 squared equals 4. So as a common factor here we have 1 over 4. Here we have e power x squared, e power 2x. 2 by first, by second. So we have 2 e power x, e power negative x. And you have to remember that e power x times e power negative x will be cancelled. E power negative x to the power 2 equals e to the power negative 2x. Minus e power x squared, e power 2x. Minus 2 e power x, e power negative x. Plus e power negative 2x. Simplify the expressions here, so you can find the final answer here is quarter times 4 e power x times e power negative x. E power x times e power negative x will be cancelled, and quarter times 4 equals 1. So the left hand side equals to the right hand side, which is 1. The derivatives of the inverse hyperbolic functions here, you can use the rules, for example, to find the derivative of a function f of x here. To find f prime, here we have a product of 2 functions. So derivative of the first, which is 10x, so you can write here 10x times second, and plus first 5x squared times the derivative of the second. Use the rule, this is the derivative of cosine inverse, and you have to remember the chain rule, as the derivative of cosine inverse x power 3 equals 1 over root x to the power 3 all squared minus 1 times the derivative what inside, which is 3x squared.